Section 2.2 continued, graphing equations. Here we have the procedure to graph an equation. Number one, we want to copy the equation. Number two, we have to choose how to graph the equation. In other words, we can graph the equation by creating a table. If we chose that, we would solve the equation for y, create an xy table, and plot the points. We also could graph an equation by slope-intercept form. Again, the procedure would be to solve for y and plot the y-intercept and then count the rise and run for the slope. Or C, we also could graph an equation by the xy intercepts. There we would find the x and y intercepts and plot the points. Our final step would be to connect to the points on the graph to create a line. Our first example, we want to graph this equation, 1/3 x plus 1/2 y equals a -1. As we proceed, you can determine the best ways to graph by either creating a table, slope-intercept form, or xy intercepts. Here, I'm going to use the slope-intercept form, so I want to solve the equation for y. So the first thing I want to do is to eliminate the fraction. So I'm going to multiply by the least common denominator, which is 6, and then I'll distribute on both sides. That gives me 6 times 1 is 6/3, which is 2x, plus 6 times 1 is 6 divided by 2 is 3y, equals a -6. Solving for y, I'm going to subtract 2x on both sides. That gives me 3y equals a -2x minus 6. Divide by 3 on both sides. That gives me y equals 3 has to go into each term, whether it goes in evenly or not. That gives me a -2 thirds x. -6 divided by a +3 is a -2. Recall, this is my slope-intercept form. And now I can identify my slope to be m equals a -2 thirds. That's my rise over my run. And my y-intercept is in the form of 0, comma b, and here b is a -2. Now, all I do is I plot my y-intercept, which is 0, -2. Then, all I need to do is to count my rise over run. Here, since this is negative, I'm going to count down 2 and over 3. And there is where I'll place a point. And then I continue until I have 3 points designated, down 2, over 3, and place another point. Then I just connect the points. And notice my slope is negative. And if my slope's negative, it must fall from the left to the right. If this was a positive slope, I would have counted up and to the right. But since it's negative, I count down and to the right. Our next example, 4x minus 3y equals a -2. Again, I'm going to use the slope-intercept form. So I'm going to solve for y. I'm going to subtract 4x on both sides. That gives me a -3y equals a -4x minus 2. Divide by a -3 on both sides. That gives me y on the left. -3 has to go into both, whether it goes in evenly or not. Negative divided by a negative is going to give me a +4 thirds x. Negative divided by a negative is a +2 thirds. Recall, that is my slope-intercept form, y equals mx plus b. M being my slope, b is my intercept. So identifying my slope to be 4 thirds. That's a rise over run. And also know, since this is a positive slope, my line will increase from left to right. My intercept is 0, comma, b, which is 2 thirds. I plot 0, 2/3. That's just off the unit of 1 on the y-axis. And now I count rise of 4. And since it's positive, I will count up 4. 1, 2, 3, 4. And to the right, 3. 1, 2, 3. Placing a point there. And creating one more point. And I count up 1, 2, 3, 4, and to the right 3. And that's just below the whole unit, since it's at 2/3. And I place a point, and then I connect with a line. Slope is positive, line is increasing, and you can see my rise over the run. 4, 3, 4, 3, and I could continue all the way up. If I plotted points using a table, or if I used x, y intercepts, I would generate the same line. Our next equation we want to graph is 3x minus 2y. I've already showed you how to use slope-intercept form. Let's try the x-y intercepts. So to find the x-intercept, I need to let y equal 0. Substituting, 3x minus 2 times 0 equals 9. Therefore, when I simplify, that's going to give me 3x equals 9. X, when I solve, is going to equal 3. That gives me an ordered pair of 3, 0. My y-intercept is found by letting x be 0. Substituting, 3 times 0 minus 2y equals 9. Solving gives me a negative 2. Y equals 9. And then when I divide by a negative 2 on both sides, that gives me y equal to a negative 9/2, or a negative 4 1/2. That ordered pair is going to give me 0, comma, a negative 4 1/2. Now I just plot the points. 3, 0, 1, 2, 3. And 0, negative 4 1/2. 1, 2, 3, 4 1/2. Then I connect with a line. By looking at the graph, this has a slope that is positive because it's increasing from left to right. I also could have used this and solved for the y value and created a slope-intercept form and graphed, or created a table and generated the same solution. Our next equation they want us to graph is 2x minus 3 equals a negative 2. Anytime that we're given a single variable, I want to solve for that variable. So here I'm going to get, when I solve for x, adding 3 to both sides, 2x equals 1. X equals 1/2. Recall from previous slides, I know that if I have just a term of x, or an x variable, that I'm going to have a vertical line. And I know I can generate that by creating a table. My x values all have to be 1/2. I always create 3 points. And I can let my y value be anything. And then I graph. 1/2, 0. 1/2, 1. And 1/2, 2. And there's my vertical line. And I know the slope, just to refresh everybody, is undefined. Our next equation is a negative 9 plus y equals a negative 3. Again, anytime I'm giving a single variable, here y, I want to solve for that given variable. So y, add 9 to both sides, is going to give me y, negative 3 plus 9 is a positive 6. Again, we recall, if I have an equation with just a y term or variable, then I know that I have a horizontal line. Again, I can create a table, 6, 6, 6, and I can go 0, 1, 2. Graphing, 0, 1, 2, 3, 4, 5, 6, 1, 6, 2, 6. And there is my horizontal line. Also, to refresh your memory, a horizontal line has a slope that is 0.